Hi guys, Dr. Orlando here, going to do our second in the series of bond vittles, and we're going to talk about ionic bonds this time. So what do ionic bonds join together? They bind ions, and that would be atoms that have a charge. How do they do that? Well, first you have to create the ions. Okay, so what you have is one atom will donate electrons. It could be 1 or 2 electrons in our examples that we'll use. And another atom will accept the electron. So you end up with this first atom donating the electron. That one, this atom, will become positive, the one that's donating an electron, and the other atom will become negative. Okay. So one atom becomes positive, one atom becomes negative because of the transferring of the electrons. And then simply opposites attract. So the fact that one atom has a negative charge and one atom has a positive charge, they're drawn towards each other, so they hang out together. Okay. So our example that we're going to use is classic, and it is sodium chloride, which is table salt. Okay, so if you draw the Lewis dot structure, and I know you guys have been looking at this in your chemistry book, the Lewis dot structure for sodium looks like this. One little dot because it only has one electron in its outermost shell. If you need to, draw out the shell model for it, and you would find that it has just one in its outer shell. Chlorine has 7 in its outer shell. And if you would recall how many, okay, sorry about that, had to walk away. Okay, so the chlorine has 7 in its outer shell. And remember, these are happy when they have 8 in their outermost shell. So some of these atoms will want to take electrons from other, or will accept electrons from other atoms, and some will donate them. Well, you can see a perfect setup here. This electron from sodium will gladly go over here to chlorine, because the sodium, once he gets rid of this guy, once he gets rid of that electron, the next level down, his second shell, has 8 electrons. So he's happy. That octet rule. Don't forget the octet. It's an E. Octet rule, that 8 is like the magic number for the shells, for the second and third shells. So when you get 8, you're happy. Okay. All right, so what happens? Well, that goes over there, right? And when that happens, sodium, excuse me, gotta pick up my right color there. Sodium is going to pick up it's going to donate that electron. So it will pick up a positive charge. That's where I was going with the pickup. It's going to get a positive charge because it lost an electron. And chlorine is going to get all of the electrons now. So it has 8. And it's going to get a +1, excuse me, it's going to get a -1 charge. Okay, so when you're doing these Lewis dots, they like to put brackets around the ion that gets all the electrons to kind of point out like he gets to keep them all, they're all his. Okay, so sodium is happy now because his outermost shell is filled. His outermost shell is now his second level, second orbital. And chlorine is happy because it's filled its outermost shell by taking the one from sodium. Okay, so that's the Lewis dot structure for sodium chloride. And you can see how they donated and accepted, and now we have charges. Now, because this chlorine has a negative charge and this sodium has a positive charge, they're going to hang out by each other. They will stick together, okay, and form that salt. Okay, however, having said that, ionic bonds are fickle. They will break up easily. Imagine this here. Imagine a beaker of water. In this beaker of water, you have lots of water. Water is H2O. Make this bigger. There we go, so I can draw it a little easier. And remember from our lecture on covalent bonds, on polar covalent bonds, which is what how water is made, how it exists. These bonds between the hydrogen and the oxygen are polar covalent bonds. So you find that these guys have charges. The oxygens are partial negative, the hydrogens are partial positive. I'm just going to draw them like this. Now you know that they are partial, they're not full charges. Negatives and positives. So this is just a beaker of water sitting there. And what do you see? You see a whole bunch of positives and negatives. So what happens when we take let's make sodium chloride red. Take sodium, which has a positive charge, and chlorine, which has a negative charge, and it's together because it's in our little salt shaker here, and we drop it in there, right? What happens? Well, sodium gets in there, and you know what? That bond is fickle. Sodium has a positive charge. It's going to be attracted to the negative charges of oxygen. And chlorine has a negative charge. It's going to be attracted to all those hydrogens. So we would say that it dissociates. That these should be an Na plus. Okay, we do say that ionic bonds are broken by water, okay, and that ionically bonded molecules dissociate. Dissociate, I can't write that very neatly, can I? Dissociate in water. They dissociate with each other because there's lots of other positives and negatives for them to be attracted to. All right, those are ionic bonds. If you have any questions, feel free to email me or call me. Have a good day.